This is the last good evening at this conference, I guess, at this session. Well, your last name is such that whenever we see it, we understand perfectly well what the presentation is going to be about. Well, I can tell you about nitrogen compounds as well. Is multiverse connected with coroutines? Well, I submitted the presentation title, and then I started thinking, what should I talk about? Marvel cartoons or something else? But then I was given a template, and I decided to talk about space and multiverse and universe. Well, I thought it was about cartoons with the wolf in MMA fights.
Не прибавишь, не убавишь. Давай скорее, ты уже начнешь. Вот, пожалуйста, не забывайте переходить по QR-коду.
Please use QR code to go to our chatbot, and please provide feedback on the talk.
Ага. Ить? О, оно работает. Ну, да, давайте сначала представим.
Right, let me introduce myself. My name is Aleksandr Nozik, and the first part of my career was devoted to physics of nitrogen, and now I'm responsible for the Kotlin development. I'm head of the Kotlin community, so it goes to show that this is the only thing that I can promote. Well, I'm not going to go through my regalia because I don't think it's interesting for you. I'm going to be talking about two parts, the interesting part and the boring part. The interesting one will be devoted to discussing possible aspects of development. You probably heard about various development aspects if you walked around this Cyberfest. We're not talking about technologies and platforms, but we're talking about ideology. And I'll be talking about the Kotlin multiverse and the way we can marry the various universes. Is going to be the boring part. I will even show a part of the code, but you can skip it if you want. So,
Backend.
The backend universe, a neural network helped me with this image. I don't know where it stole it from. Anyway, this is a space station, and lots of spaceships are trying to dock to it. And our task is for them to load without any problem, so that JSONs do not fail, databases do not fail. And one of its features is it's highly competitive because there are lots of spaceships. The reliability should be extremely high, because if the backend fails, then everyone is going to be sad, because ice cream will not be delivered. Oftentimes, this is the main bottleneck. I mean, the input-output is the main bottleneck, because we need to route these streams very quickly. And another important aspect that backenders do not realize until they start working with front-end is that they think that everything is fine as far as the format standardization is concerned. They know the what and the how. They have JSONs, they have APIs that limit all their processes, and they never deal with raw data. Another important thing, if you work for a bank, then your solutions should be resilient for years.
Совсем другая вселенная.
This is a totally different universe, front-end. Front-enders are different, and just like a spaceship with aliens, I have no idea who they are, by the way. They try to talk to aliens in their language. It's total chaos. They try to use sign language. They don't really understand each other, though they want to trade. The specs for flexibility and changeability is high. The development cycle is a couple of years. All technologies will change over the 2 years, and you will have to change your development again. Framework knowledge. Backend is about technologies, and front end is about the knowledge of frameworks. and debugging tools are usually worse, and you have to spend much effort for debugging. There are different types of front end. For instance, you can use typical JavaScript and no multi-thread capacity. Well, you can do that, and asynchronous development, because backenders come to front and ask them, where's my thread? How come I cannot block it? I don't like it. And the mobile platforms are as far as development and ideology are concerned, they are very similar to front-end, different resolutions, different screen sizes. An app can switch off at any moment, so you have to think about how to store a current status. Data science, that's a term that I don't really like, because data science has nothing to do with either data or science, just like guinea pig. It has nothing to do with either guineas or pigs. Well, Andrei asked me to add it because there was a talk about Mojo early in the day, and that's about the data processing universe. This is what I do, by the way, system analysis. It has no programming tasks. So the main task is to come up with a conversion of some input data to get some output data. On the way, they're cleaned so that nothing is failed, especially if your incoming data is bad. There is lots of calculus, and you know, when people see that a lot of math is involved, they are shocked, and the main bottleneck is CPU. For backend, CPU is never a bottleneck, and here CPU is the main bottleneck, so it's a totally different design. And there is no such thing as debugging in data science, because everything depends on the quality of the input data. You cannot debug anything. You can generate data, but real data will differ considerably from the generated data. And the system programming is something that I will not touch upon, because Kotlin is not about that. It will be problematic to use it, and that's why you had LLVM talks because of that. And the neural network offers the following vision. You try to build a spaceship out of logs. You don't have the right tools, you don't have the right materials, you need to manually manufacture every single detail. So maximum flexibility, but it has to be done manually, you know. And at least this is what my experience tells me. And the easier the better, sorry, the simpler the better. So how is it related to Kotlin? Ideologically, Kotlin has been positioned as a language that allows you to live in various universes. It was designed for IDE that Andrei talked to you about just a couple of minutes ago. It was not designed for the mobile development at all. This is a misconception. Kotlin is suitable for most of the universes that I talked about, save for the system programming. This is a real picture of a scientist's vision of the universe. Stage one, quick expansion or inflation, and then we see a gradual expansion or inflation of the space we live in. If you have any questions, please refer them to the chat box. So what's Kotlin? This is some advertising bullshit from the Kotlin website. This is a cat icon. The proper name is Cody. So that's how we're gonna call it. It's concise, multi-platform, and fun, because, fun also stands for function, so it's a pun. And this paradigm is important for Kotlin.
Вот в этой фразе
This is a versatile programming language of the most recent generation, and the next generation language such as Kotlin are similar in ideology and development. It doesn't really matter what next generation language you're going to use because they're all similar. They are based on the same things. It's an open source language. Again, that is a nod towards Andrei's presentation. You can compile it in different locations, and it also supports various platforms and artifacts, as well as it supports programming in these platforms, not just compilation, but programming in a platform, giving the specifics of the platform. It supports JVM, JS, LLVM, and WASM. WebAssembly, both in backend and front end. JetBrains is the main developer, although there is Kotlin Foundation that includes Google and a dozen more companies who support development of this language. And that's exactly what it says in the last bullet. So it's not a single company language as is the case with the Microsoft language. So I told you that there will be some physics. The inflation stage is when you develop at a rapid pace. It takes literally seconds. For instance, our universe was shaped within a couple of first seconds. Multiple interesting things happened during the first few seconds. And well, when I'm invited to deliver a talk on cosmology, I'll be happy to do that. So Kotlin appeared in 2011. About the same time, we saw TypeScript, Julia, Rust. So they all appeared within a year. Swift appeared sometime later, if I'm not mistaken, but it was developed also about the same time. In 2012, open source source code was provided. In 2013, a more stable build was provided. The JS dialect appeared in 2014, and the first stable coroutine was issued in 2016. Even the logos changed quite frequently. In 2017, very few people really expected, but Google Google started supporting Android with Kotlin, and again, no one planned it because the language was never intended for mobile development. It just turned out to be successful. 1.2 version appeared in 2017. In 2018, well, it says Ktor appearance of Ktor. It was not a really great milestone. 2018. Official support of Kotlin Native, 2020 official support of new compiler for JS, and 22 to 2024 we see improvement of stabilization, and Kotlin 2 release happened just recently. It contains a new compiler, and it doesn't add anything new, but it simplifies lots of things, and it paves the way for further development. In other words, we are now in the modern universe. Galaxies spread around, but nothing is on fire, and the hyperlink is at the bottom of the slide for if you want to get more details. And for the Kotlin multiverse, it's a multiverse, so we're talking about different platforms, different development approaches. There are two similar concepts which are still different. Andrei Breslov's Kotlin default language, that's the first one. It might not be the best language for any task, but you can actually discharge any task if you don't know what it is that you want. I like this concept. The second one, unfortunately, I don't have such a beautiful shot for that, but this concept was announced by Roman Yelizarov, and the main idea is multiplatformity first. So Kotlin should work in different platforms. Very similar concepts, but there is a difference. And whichever you like better, use it. Let's move on. So how does that work? how does the multi-platform capacity works? How come we can jump from one universe to another universe, work with them? And how do you make sure that the same tool can be used in different ecosystem libraries and development approaches? The secret is that we don't try to apply the same tool to everything. Kotlin is actually a combination of different languages. For instance, Kotlin JS and Kotlin JVM are different. Kotlin JS has structures that do not exist in Kotlin JVM because the keyword is dynamic, which is a non-typical object, a JavaScript object. Kotlin JVM offers synchronization. In other words, in JVM we have monitors that synchronize everything with the help of VM tools. In Kotlin native, you can manually limit the policies. And the secret is that all you have to do is single out the Kotlin common dialect and then add those parts of code that are specific for your platform. So that's a specific for your platform dialog, and you use specific libraries. And this is the main difference between Kotlin and C++ and Dart that uses all the same libraries. You can use your native ecosystem. And this slide approximately describes the way it's done. You have a common code, and during the build, you put it all together. Actually, it's way more complicated because, as it says here, the common dialect might not be used for all the platforms, but for a subgroup of platforms. And in some pivots,
компании Apple.
It makes sense to use Apple ecosystem.
Самого Apple компилироваться.
They ban everyone but Apple to compile their binary code, and this is a pain point. Only GitHub runner can solve this problem because this is the only runner that can compile for Mac. Otherwise, you will have to use the Mac proprietary product. In addition to that, they have multiple platforms, x86, M1. These are different CPUs with different architectures. So there are lots of funny quotation marks things inherent in that. A very important moment that I want to mention. These are add-ons, but what if we need to recall some functions from the common code that operate in different way in different platforms? And this is a unique feature. As far as I know, no one uses this mechanism so far. It makes the compiler more difficult, it makes the build more difficult, but it allows you to do these things. In the common code, you can call some functions expect, and then you can do implementation specific to a platform. This is the simplest example that I copied from my code. This is a precise conversion into int. JVM has this function, and JVM allows you to quickly call up this function. Other platforms do not. So all you do is use the native function in JVM, and in other platforms you have to come up with a less effective but more versatile function. The Kotlin libraries, original Kotlin libraries, don't have builds for JVM because they just refer to the standard Java library. For other platforms, there are different executions because in JavaScript you don't have standard data sets for working with bytes. These are nuances that you have to keep in mind, and in your code you won't see any expect actuals because there are libraries that already cover that. But anyway, this is a trick that allows our spaceship to to fly in a totally different universe.
Педантов, как это работает внутри, я выдернул этот слайд прямо из обучения.
As for the internals, shown below is the hyperlink to the training course that I copied this slide from. The internals are quite complicated. You have to break the data down. There is a backend compiler. There are two levels of internal presentation because there is the front-end IR, there is
Платформу, это может быть JavaScript, JVM.
backend IR, it could be LLVM bitcode that is used in the native.
В общем, вся эта штука довольно много.
And this is a multi-level thing, but end users don't need to know about that because it works and everything is fine. For this to work, the build tools have to be complex as well. It's not just like running a single file compiler. At basic level, you need to split the code to generate front-end IR, back-end IR, generate metadata to link the different libraries. Then you need to update the JVM dependencies because we're not writing on C++. Then you need to compile the JVM bytecode. Then you need to
Внутреннее представление превратить в
transpilate JavaScript. Then you need to build JS dependencies.
В обратную сторону.
And it's just the reverse because in JavaScript you use modular from Webpack to build dependencies. And before that, you need to install nodes. And only after you do all of this, you integrate one thing with the other to build a full stack app, and only after that you can distribute it to the server. So the tools are quite complex, and I did not mention the entire list because we need to test things. There are lots of binders as well.
Опять же, сейчас сошлюсь на Андрея.
I'm going to refer to Andrei once again. He talked about plugins for developers and plugin tools for developers. Here we can use build plugins. I can hardly imagine Kotlin on CMate. I guess you can, but it's going to be suicidal. But in this particular case, we already have every prerequisite tool in place. All you need to do is activate build plugins and subsystem plugins such as Compose, Ktor, configure the target, the JVM, JavaScript, the way it's going to be compiled, and so on. And then we activate dependencies which are specific for every platform. Every platform exists in its own ecosystem of dependencies, and only after that do we run the app. Another important thing that I want to mention is that if you want a full stack app, then these two universes and have to be mirrored, and they have to be put inside the full stack app. In Gradle, it's easy to do. This is the code. This is the entire code required to do that. But nevertheless, you cannot forget about that. The next part will be about a very simple app that is based on a multi-platformity. So it's an app where both the backend and the front end is written on Kotlin. So we have Kotlin common dialect. It could have large common logic.
Вы обычно в Common храните модели.
In Common, you usually store models so that data models are the same for different universes, so that you can use the same programming language. As for serialization, I will be talking about that later. I'll describe the way it looks in backend. There are lots of tools available for backend, but I'm going to give you a specific example.
Кнопочку то не нажимается, нажимается 2 раза. И, наконец, мы с вами посмотрим, как это...
And finally, we will take a look at the front end as well. There are lots of frameworks for the front end, and I'm gonna show you how to use Composer HTML. It's not the most popular one, but it's very small size and convenient. Right, so the objective is as follows. Let's say we have one status, and I wanna build a counter, not where you press a button and a figure changes. I want this counter to be synchronized for all the users. It's a simple task, but it will allow you to use all the web services, save for the link with the database. I'm not going to talk about that. If you're interested in that, come to the G-Point workshop. There you'll see a link with the database. But if you can synchronize actions of various users on the server, on the client of the server, then you'll be able to build any app. And, we're not going to use a conventional approach. Conventional approach is REST API, and I'll be talking about a more advanced thing. Head-on flows of events. So this is what we're going to use. And outside of Kotlin, many people use gRPC, but in Kotlin it's way more convenient because your models are synchronized. It looks just like this. The client sends to the back server the control thread, and the data flow goes from the server to the client. In this case, you get one source of truth. As for the data model, in Kotlin it looks like this. You have events that are fed from the front to the back end, and they tell you what needs to be changed in the database. And we have events with data. This is an additional abstract parameter.
Не надо. В данном случае это просто демонстрация, показывающая, что у вас в будущем этих типов событий может быть гораздо больше.
In the future, the number of types of events might change, and
события в другую сторону не надо их.
Events that go to one side and to the other side should not be confused. Otherwise, you will run into additional challenges that you need to avoid. What is serialization? I hope you all understand what that is. It's presenting data from a model in a text form, in a byte form, and vice versa. And you can go in different ways about it. You can do this manually. Please raise your hand if you do it manually. No one. Right. You can do reflective serialization. In other words, when the program runs, you can analyze the structure of classes. Who does the reflective serialization? Very few people. What about the rest of you? Don't you do serialization at all? And you can do code generation. One of the examples would be OpenAPI that allows you to do that. You can generate serializers. Please raise your hand if you do this. So I guess everyone. Okay. Kotlin X serialization is serialization that goes through the code generation and the plugin of the compiler. I will be referring to Andrei all the time, so I guess...
Как у нас, Kotlin у нас мультиплатформный язык, значит, Kotlin сериализация — это мультиплатформная, мультиформатная библиотека, которая позволяет делать. Кстати говоря, никто не запрещает, конечно, использовать Kotlin, он тоже хорош, но, правда, работает только на Java. И что, кстати говоря, блокирует его использование?
And by the way, that blocks its use in the full stack app and the multi-platform apps.
Как это работает?
The way it works is as follows. We take the serializable classes and a sample of this class. So class is a description, and there is a sample that already stores specific data. And then, when we compile it, we generate a scheme. And in this particular case, it will be a K serializer that enables the conversion. Or you can do this manually if need be. Then we take real data and use the scheme to generate a tree or a flat structure of real numbers, depending on what you use. Only after that do you use the JSON encoder, and this tree is represented in the final result. Approximately everyone follows this flowchart, but I decided to show it to you once again to demonstrate the way it works. And since it works at the stage of compiler, it does not require access to your classes, which means that it works both in JavaScript and in native compiler.
Например, сериализация. Так, поехали немножко.
Okay, now let's speed up and let's see what we can do with the code that has become too boring. Backend. Since Kotlin is rooted in JVM, it's got a multiverse of backends. These are the ones most popular. They are the JetBrains bestsellers. Spring, 80%. Quarkus, a little bit less. Ktor, Micronaut, Grails. Grails is using grooves. It's like Ruby on Rails. Vaadin is an interesting concept. It's developed for full-stack apps, not for backend specifically. We're going to use Ktor today. Let me warn you that they have different approaches and different target audiences. Spring and Quarkus are frameworks for enterprise, for typical standard routine tasks, and Micronaut and Ktor are for customized tasks and microservices. So this is Ktor. It's our spaceship, a small one, a quick boat. Really a speedboat, and you can install additional features onto it, such as a JVM-based server with different I/O engines. What do I click? There is also a server based on native. It's not yet tried and tested, but it's got potential. And then there is the response component of Ktor clients for platforms supported by Kotlin. There are also other things that can be connected with plugins, and you can use them as necessary as our application becomes more and more complex. Here you can see, well, apart from this a little component here is the code of the server. This is how we install two of our plugins. And we also set up a flow of events. We add events, they will be dispatched and relayed automatically to the upstream flow. There is an error here. I decided not to fix it. Maybe you are going to find it yourselves, or maybe you can tell me right away where you see the error. Routing, what you saw on the previous slide, is here. All of it. I'm using here our socket. It's another technology that allows you to relay the events in the format that's natural for reactive flows. That's it. That's all of the server code. There is nothing more to it. So two types of events are processed. We sign. There is a relay event and a subscription to updates. That was the backend. Now let's go to front end. Let me first show you how it works. This is the response. Same language. In fact, you don't see any JavaScript here or any of its special features. We write in Kotlin, and Java specifics is in the library. We get the client up. We get the incoming and outgoing event flows in symmetry, and we also do a render of our element in the under composer block. Composable is a separate story, and of course I will not be able to cover it during today's talk. It's a framework for UI, it's multi-platform, and it has a render engine that's used for mobile platforms and desktop, and in ASME they've got the Composer HTML. The important thing is it fixes the issue of changeable state. As automatically, if the state is changed, the picture will be redrawn, and you don't need to do anything. Don't need to do anything with your hands. So I need the slide to show you that this is the front end, and all the special features. Padding. Anyone does? Have you ever done HTML? So if you have this experience, then probably you know that what I'm showing you now is HTML. We are in the front-end world. You live in the front-end world. It means that you are in the HTML world. Even CSS is built in. Front-enders would hit you on the head for seeing something like that. But we are aliens, so that's all right. We will build CSS into the code. Right here. Yes, you can bypass that, but I decided not to. For front end, there are fewer Kotlin-based solutions. Still, there is a choice. Kotlin React is the best seller, but I don't like it much because it's very JavaScript specific. You have to dive into the front end world very much to be able to use it. There's Cobweb, which is a wrapper for Compose HTML, which allows you to do everything in a much more flexible manner. Kvision is, for those of you who are familiar with JavaFX, it's for the fans of JavaFX and HTMX. It's not about Kotlin, but Wittgenstein loves it very much, so I couldn't but mention it here. This is the result. I didn't show you a demo, but there is a link at the end of the presentation that will take you to all the demos. This is a code. You click it in one place, and all the users, I mean, it will be updated for all the users because the flows are reactive. And of course, if I did not say anything about issues, then people will accuse you of being one-sided. So one of the big problems there is SIG bundle. The native bundle for React.js is 20 kilobyte, and the bundle for Kotlin React is 100 kilobyte. Still peanuts, but if it's a Compose HTML, then the bundle is 300 kilobyte, and if you also connect Ktor client and coroutines, it's 1 megabyte. In the modern world, this is also kind of peanuts, but 1 megabyte is already noticeable. It's not 100 kilobyte. And yes, compression helps. And yes, you can enable it on the Ktor server with just one click. And you don't need to use the Ktor client, although you will be sacrificing some of the advantages of this technology. The problem for me personally is that you still have to live in the HTML universe, and you have to hit your head over CSS, but it's the only thing that is the only way to get solutions that would be native to this world. You can take opinionated frameworks, less flexible, but CSS will already built in, or you can learn to assembly a CSS framework yourself. And then there is also the Compose multiplatform. For many people not outside of the Java world, they say no to Ktor because it's not Spring. It's not Spring, we don't need it. Well, people phrase it differently. It doesn't know how to work with databases. There is no special authentication or something. But the solution here is take Spring. You love Spring? Okay, take Spring. Or you assemble this once with your own hands. Take the database management solution that you enjoy and build your own solution. Ktor, for us, it's a perfect tool because it's lightweight for data management and visualization, and the code on the front end. It doesn't happen quite often, but in our visualization system, something what you see, the difficulty is not with the back end, but in the front end. Do not take Ktor if you are running crude, you're working with a crude routine banking app.
уже работает на...
Or if there is already a standalone front-end team that uses JavaScript, then do not try to retrain them. Keep using JavaScript.
Подошли к концу нашего...
I'm kind of almost on time. We're approaching the end of our journey. Kotlin multiplatform is a very flexible technology. It allows us to use the same one language and to travel through different realities and universes and to speak